This video is a new Tetris tutorial. Using the Python language in the Pygame library, here we will take a detailed and optimal approach on how to create a very nice and complete game that you can see on the screen. So Tetris is a puzzle game invented and developed by the Soviet programmer Alexei Pajitnov in 1984. This game has become so popular all over the world that by the number of sold versions it surpasses any other computer game in the history of the game dev. The game is based on 7 figures called Tetraminos, each of which consists of 4 blocks. And the whole point of the game is ingenious and simple. On the playing field we move and rotate Tetraminos to make a full line of blocks that disappears and we are awarded points. Such gameplay turned out to be very exciting and is unlikely to ever get old. So let's have some fun and recreate this game. So let's start with the fact that Pygame is already installed and the development environment is set up. Then for the initial setup, there will be a main file that contains a typical application class for the Pygame library. Here we create a window of the specified resolution and there is a main game loop in which 3 methods are called, the event checks method, the update and draw methods. And for convenience, we will use the settings file. Currently this file contains the values for the frame rate, the color of the playing field, and here the window resolution is calculated based on the size of the tile and the size of the playing field, since in Tetris the size of the visible part of the playing field is 10 by 20 tiles. So, as we can see, we have a window, the resolution of which corresponds to the Tetris playing field, and if you want to follow this tutorial, then these files with the initial code are available at the link in the video description. Now let's talk about the further structure of the project. So in Tetris, each Tetramino is made up of 4 blocks, and I suggest making each block an instance of a separate class so that you can use sprites, which will make the game pretty nice. In turn, all 4 blocks will be controlled by an instance of the Tetramino class, and all Tetraminos on the playing field will be controlled through an instance of the Tetris class, which will be created in the application class. Such a simple structure will make our application flexible and scalable, and allow us to add some special effects in a convenient way. And then let's create a Tetris file. Here we will import the settings in the math module, and write a class of the same name, the input of the constructor of which is an application instance. And there will also be 2 main methods, update and draw. So now we can import the Tetris class in the main file, and create an instance of it in the application class. And then let's call the update and draw methods of this instance in the appropriate methods. Let's run the program, and see that everything works without errors. And we can say a partial sketch of the project structure has already been completed. And by the way, the display of our playing field can be improved by drawing a black grid on it. We will do this using the draw grid method. Here we iterate over the size of the field and draw the corresponding rectangle equal to the size of the tile. Let's check, and make sure that the grid is displayed correctly, and we can move on. Now let's create another file called Tetramino, and here we will have 2 classes, the block class and the Tetramino class, which has access to an instance of the Tetris class. And for now, let's write the update method here. And then in the Tetris file we can import the Tetramino class. Let's create an instance of this class, and call the update method accordingly. And thus, we have implemented another abstract layer for Tetramino, and it remains to deal with the block class for which we provide for the use of sprites. Then, to use sprites, the best choice would be to create a sprite group, on which you need to call the draw and update methods. And please note, this group will contain all the blocks of all the Tetraminos on our playing field. Then let's check again that the program runs correctly, and we can move on to the block class. So, since we are using a sprite group, the block class needs to inherit from the sprite class of the Pygame library. Then let an instance of Tetramino and the position of the block on the playing field are passed to the class constructor. And by the value of the position of the block, we mean its position in the coordinate system of the playing field 10 by 20, that is, the value of the position of the block will not take into account the size of the tile. And to draw the block, you need to pass the sprite group to the constructor of the parent sprite class, while you need to define the image attribute, let it be a square with the size of the tile and filled with orange. And it remains to determine the rect attribute in its position, but taking into account the size of the tile, in order to correctly draw it on the screen. And for the test, let's create some block in the Tetramino constructor, and if we run the program, we see the block is displayed at the specified position. And now let's figure out how to make Tetramino from blocks. For example, Imagine a T-shaped tetramino in its local coordinate system, and let's agree that the origin is the pivot point of each tetramino, and then it is easy for all blocks to set the appropriate coordinates. Now in the settings file, we can set a dictionary, the keys of which will be strings defining the shapes of tetraminos, and the value will be a list of block coordinates, where the first element will be the pivot point. And then, having done the same work with the coordinates, we add all the remaining tetraminos to our dictionary. Now in the Tetramino class, you can define a shape attribute that will correspond to the key in the dictionary. And then the blocks attribute will be a list of instances of the block class, the positions for which we will get using the shape attribute. If we run the program, then our tetramino will be at the origin of the Pygame coordinate system, so we need to define some offset for the blocks to display them in the right place. But for this, I propose to switch to operations with the 2D vector class, which will greatly simplify our code. And for example, let's define the initial offset equal to the center of the playing field. Then the pos attribute can be defined in the block class. This will be the position of the block shifted by the offset value, and due to vectors, the previous arithmetic operations have been simplified in terms of the amount of code. And if you run the program, we will see the correct display of our tetramino, and you can also check whether the coordinates for all other tetraminos are set correctly. Okay, and now from the random module, let's use the choice function to determine a random tetramino from our dictionary. Let's make sure that every time we start the program we have a random tetramino, and let's move on to the implementation of the tetramino's movement on the playing field. And since a block or tetramino can only move in the left, right, and down directions, we define these movements in the dictionary as increment vectors for the x and y axes. And now, in the tetramino class, we will write the move method, where, depending on the value of the direction parameter, we get the increment vector and add it to the position of each block. And then, through the update method, we can move the tetramino down. But if you run the program, we will see that there is no downward movement. This is because we need to update the rect position values for the blocks each time they change. For this we will make a separate method and call it also through the update method. Let's look at the result, and as we can see the tetramino is now falling, but moving down is very fast, it's 60 blocks per second as a frame rate value. Then let's first change the initial offset so that the tetramino appears in the middle of the top of the screen. And as a temporary solution to the fast downward movement we will define some delay for each frame, but again, this is a temporary solution and later we will make more advanced game speed control. So as we can see the tetramino is falling from above, and now let's deal with the control of its movement to the left and to the right. To do this, we will write a control method in the Tetris class, the input of which will receive information about the pressed key, and depending on whether it is the left or right arrow key, for tetramino we will call the move method with the corresponding direction value. And then in the application class in the event check method in case of a key press, we will call this control method for an instance of the Tetris class. And so we have the ability to control the tetraminos, but the delay introduced to slow down the fall now also affects the movement delay when a key is pressed, so let's fix this problem. In the settings file, I propose to define the value of the time interval for the animation. And then we can write a method to set the timer. In this method, we will define a reserved user event value that will appear after a set period of time, and each time this event occurs, we will use the value of the animation trigger attribute, and all movement in the game will occur according to the value of this trigger. And now we will call the tetramino update method only if this trigger is true. And then it remains to remove the previous delay, and look at the result. Thus, we got a very pleasant and responsive control, and which does not depend on the frame rate. And let's now look at the implementation of collisions for our game. Then, for the block, we will write the isCollide method, which takes a certain position as input and checks whether the block is inside the playing field. If the block is inside, then there is no collision, and if it goes beyond it, it returns the true value. And for the tetramino class, we will write a method of the same name, but which takes positions for all 4 blocks, and using the map function, we will call a collision check for each block, and the any function will let us know if at least one block has a collision. And then we will proceed as follows, we will form new positions for the blocks, taking into account the value of the direction of movement, and then we will check if at least one of the blocks has a collision at the new position. And if there is no collision, then we move all the blocks to new positions. Let's run the program and check the operation of such a collision system, and as you can see, the Tetramino does not go beyond the boundaries of the playing field, but when we land, we can still move the Tetramino. And here you can define the landing attribute, which is initially false, but as soon as a collision occurs and the direction of movement is down, it will become true. Then in the Tetris class we can write a method for checking the landing of a Tetramino, and when this happens, we will create a new instance of the Tetramino, and we will call this method through the update method. So if we wait for the Tetramino to land, we will see the appearance of the next one and we already have the beginnings of gameplay. But as you can see, Tetraminos fall on top of others, so let's continue to refine the collision system. And to do this, we need to create a 2D array according to the size of our playing field, and initially filled with zeros, we will put information about the landed Tetraminos into it. Along with this, we need a method that will allow all Tetramino blocks to be moved to this array, and here the array performs double functionality, that is, its element stores a pointer to the block object and will also be used to calculate collisions. And of course we will call this method after the Tetramino has landed. And then it remains for us to add an additional check to the collision method to see if there are other blocks in the array, and at the same time we will not take into account this array when at the beginning the block is above the playing field. So let's wait for the next Tetramino to land on the previous one. And as you can see, everything is fine, and thus our system of collisions has been finalized. And now let's implement the Tetramino rotation. But let's remember how to rotate a point around another. Let's say we need to rotate point A around point P by 90 degrees, and the first step is to subtract the coordinates of point P from point A. Then the coordinates of the resulting point are rotated by 90 degrees. And the last action is to add the coordinates of point P, and as you can see, this requires 3 operations. And now we can write a method to rotate the block position by 90 degrees around the pivot point according to the above theory, and for this we use operations with vectors. And the rotation method for Tetramino will be the following. We know that for each Tetramino the rotation point is a block with a 0 index, then we also calculate the new rotated positions of the blocks and check them for collisions. If there is no collision, then we assign a new position to each block. And we will call this method in our control method of the Tetris class when the up arrow key is pressed. So let's check. And as you can see, Tetraminos rotate correctly around their rotation points, but all the blocks eventually merge in one color, and until we use sprites, we can slightly improve the graphic component. Then let's go back to the block class, and instead of filling its surface with a solid color, we can draw a nice rectangle with rounded corners. Let's test the program again, and in this way the Tetraminos look much nicer. And as you can guess, it remains to implement one of the most important methods. This is a method for checking full lines. And since we assume the removal of the blocks themselves, let's define the alive attribute for the block. Also, we will need a method to check whether this block is alive, otherwise we remove it from the sprite group, and we will call this method through the update method. So the method for checking full lines, we will start by defining the row variable, which is equal to the last index in the field array. Then we start iterating through the array from bottom to top and left to right, and using the row variable, we simply reassign the values of the elements of the array, because the value of row is now equal to the value of y. Next, we check the number of blocks in the current line, and only if this line is incomplete, we reduce the value of the row variable by 1 to reassign the next line, but if the line would be full, then the value of the row variable does not change and we simply skip the full lines and overwrite the incomplete ones. And besides, we need to exclude blocks from the sprite group so that they are not displayed, and rewrite the values of their elements to 0, so that the collision system works correctly. And we must not lose sight of the fact that the blocks themselves have a position attribute, which must be reassigned according to the new values of the indexes in the array. So we will call this method through the update method, and we need to test the operation of the logic of this method. Let's play our Tetris and collect some complete lines. And as we see the full lines disappear as expected, the collision system works correctly, and we can say that the main core of our game is ready, and now we can do the rest of the improvements. For example, let's make the Tetramino fall faster when pressing the down key. To do this, it is easier for us to define a short time interval for fast animation. And then we will simply create another timer. This will be a different value for the user event, and we can simply duplicate all the other attributes, but only add the fast prefix. And then in the Tetris class, you can create the speedup attribute. When the Tetramino lands, we will set it to false, and when we press the down key, we will set it to true. And according to the value of this attribute, the appropriate trigger will be selected, that is, the time interval at which we will update the entire logic of the game. So the gameplay of our game has become more interesting, and now, at the right time, we can accelerate the fall of Tetraminos. Well, let's start to figure out how to use sprites for this game. I will use handmade sprites. As you can see, I try very hard to draw a beautiful square picture. Well, so that they are diverse, I will make several of these pictures in different colors. And in the end, all the sprites are located in the Sprites folder, which is located in the Assets folder, and so let's define the path to this Sprites directory in the Settings file. Then, in the main file, we import the pathlib module, and create the load images method. Here, we will first get all the PNG file names using the pathlib module, and then using these file names we will load them using the Pygame library tools. And you also need to scale them to the size of the tile, and now all sprites will be available through the self-images attribute. And in the Tetramino class constructor, we can select a random image from the images list using the choice function. And then for the block class, through the Tetramino instance, we will access this image. And let's look at the result. And it is clear that the use of such homemade sprites greatly transforms the graphic component of the game, and it becomes much more pleasant to play. And the next step, I propose to implement such an element as information about the next Tetramino, so that we can plan our actions in the game. But for this we need to expand our window, then let's define the scaling factors for the playing field, and based on them we calculate the resolution of the window, which will be a little wider. And we also need some color for the new background. And then in the application class we apply the new window resolution, and also change the background color. And if we start the game, we will see a larger window, but there was a small problem with the playing field and we need to return its color back. And to do this is quite easy, just fill with the previous color a rectangular area equal to the playing field. So everything is now displayed correctly, and we have an area on the right where we can show the next Tetramino. So in the Tetramino class, let's define another attribute called current, which will default to true. And now in the Tetris class, you can create the next attribute of the Tetramino. It will be an instance of the Tetramino class, but the current parameter is false. And if you run the program, then on top we are some kind of Tetramino, for which we need to determine the offset in order to display it in the right part of the window. And after doing some work in advance, we can determine this offset in fractions of the size of the playing field. Then in the constructor of the block class, we can define an attribute for the next position for which we apply this offset. And now the position of the block for drawing will depend on the current attribute of the Tetramino to which this block belongs. So we can see the display of the next Tetramino, and it remains for us to implement a little logic to change the Tetramino from the next one to the current one. To do this, we return to the Tetris class in the landing check method. And when the Tetramino has landed, we make the next Tetramino the current one, and create a new instance for the next Tetramino. Let's run the game and make sure the Tetraminos change correctly. And as you can see everything is working fine, but you may have noticed that we have no check for the end of the game, so let's implement this method. So in this method, we will simply compare the y-coordinates of the 0 block and the initial offset, which means that the Tetramino has not moved anywhere, that is, the entire field is filled. But this method must be applied after the Tetramino has already landed, and if it has not moved, then we reinitialize the Tetris class constructor. So let's lose on purpose, and as you can see, this approach works great and the game restarts. And the next element I propose is to create text inscriptions in our game, since there is plenty of space for this. And since I don't want to use standard fonts at all, I decided to choose a font for my wonderful sprites that matches their style. Then, having downloaded this file, I placed it in the font folder, and let's define the path to the font file in the settings. And I propose to create a text class in the Tetris file, which will have access to the application instance, and it will also have a draw method. And therefore we need to import this class in the main file, create an instance of it, and call the draw method in the application class method of the same name. And to work with fonts, we import the free type submodule of the Pygame library. Then we create an instance of the font class, specifying the path to the font file. And now in the draw method we use the render to method, for which we specify the rendering surface, the position for the text, then the text itself is the name of the game, and for the font we select the color, size and background color. Let's run the program, and now at the top right we can see the name of our game displayed in a rather nice style. So in a similar way, I added a few more text inscriptions. And so the game now has inscriptions for the next Tetramino, the inscription score and the value of the points scored. And if you notice, I chose the position for these inscriptions in proportions relative to the size of the window. This is done so that if you want to change the size of the tile, for example, reduce it, then as you can see, all elements of the game change proportionally, since even the size of the window is based on the value of the tile. So in the current view, the score is just text, so let's implement this functionality for real. Then, for this, we will define a number of attributes in the Tetris class. This will be the value of points scored, the number of full lines, and we will define a dictionary with which, depending on the number of collected full lines, we will award a certain number of points. Next, we will write a method in which we will accrue points depending on the number of full lines, and after accruing them, we will reset them. And accordingly, in the method of checking full lines, we will count them. And then we will call the getScore method through the update method. And now it remains in the text class, insert the value of the points scored, and access to them we will do this through the application instance. Well, let's have some fun and play our Tetris to collect full lines. And as you can see, the scoring mechanism works and everything is displayed correctly. And frankly, our game is completely ready, but still, let's implement one more element that will make our game quite original, and I mean the special effect in which the blocks of the collected lines will effectively scatter. So let's go back to the block class and define the following attributes. This will be a copy of the image block sprite for which we will set some transparency value, and define a random block speed value. The method for the special effect will be that we will replace the current image with a transparent one and start moving it up, but in addition to this, we can implement rotation of this block. But to use this method, you need to make a method to set the duration of the effect. And then let's define the number of cycles for the duration of the effect, and also the counter of these cycles. Now let's write a method that determines the duration of the effect. We will count the cycles according to our animation trigger. When the number of cycles passed exceeds the set number, this will mean the end of the special effect. And accordingly we will launch this effect in the case when the value of the alive attribute is false, and after the end of the effect we will remove the block from the sprite group. Well, let's collect the lines in our Tetris again and look at this effect. And as you can see, it's a pretty cool effect, and maybe you can come up with something else. And so our game is ready, and since I really like Tetris, this is probably the case when you create a game and then play it with pleasure.